What is coordination in relays and switchgear? Imagine a power system where a fault happens somewhere in the network. You want only the part closest to the problem to shut down, not the entire system. That's where coordination in relays and switchgear comes into play. It's like a well-organized team where each member knows exactly when to act to prevent chaos. In simple terms, coordination means setting up protective devices so that only the relay nearest to the fault triggers the circuit breaker to disconnect that part of the system. This way, the rest of the power network keeps running smoothly. It's a smart way to protect equipment and keep power flowing without unnecessary interruptions. Relays are devices that detect abnormal electrical conditions like too much current or voltage drops. Switchgear includes components like circuit breakers and fuses that control and protect the electrical equipment. When a fault occurs, relays send signals to trip the circuit breakers. Proper coordination ensures that the relay closest to the fault trips first, while others stay inactive. To achieve this, engineers set the relays with different time delays and current thresholds. For example, a relay downstream might trip in just 0.2 seconds at a certain current, while an upstream relay might trip after 0.4 seconds at a higher current. This difference in timing helps isolate the fault without shutting down the entire system. Another key aspect is maintaining a time margin, usually between a quarter and half a second. This margin accounts for breaker operation times and relay response delays. Digital relays respond faster, so they can have shorter margins. Engineers use time-current characteristic curves to visualize and adjust these settings, ensuring everything works smoothly. Different types of relays are coordinated based on what they protect. Overcurrent relays are common in distribution systems, set to trip at specific current levels and times. Distance relays, for example, measure how far away a fault is and trip accordingly. In practical terms, coordination means that when a fault happens, the relay within the switchgear closest to it sends a trip signal to its circuit breaker. This isolates the problem quickly, protecting the equipment and personnel. It also minimizes the area affected by the outage, helping keep the rest of the system stable. In essence, coordination in relays and switchgear is about organizing protection devices so they work together in a hierarchy. This setup ensures faults are isolated efficiently, with minimal disruption, and keeps the power system safe and reliable.